Okay, in this tutorial we're looking at trigonometric symmetry properties including the unit circle. Okay, so I'm going to jump straight into the unit circle before I go into some of the other identities, okay, because the unit circle is an incredibly important tool and useful tool when it comes to our work on trig. Okay, so there's a fair bit of information here on this page. So I'll start with the unit circle itself, which is drawn in the middle, okay, and then talk about some of these other things around the outside. Okay, so the unit circle here, okay, we have a radius of 1, so it's a circle with the radius of 1. Okay, we measure our angles around anti-clockwise from here. Okay, so start over here, right, and so this is taken as 2 pi or 0 if you like, as well. Oops, sorry, 0 not theta, 0. Okay, and we're measuring this way. Now, we want to be measuring our angles most of the time in radians. Okay, radians should be something that we're reasonably familiar with already. Okay, so radians splits a circle into 2 pi radians. Okay, so I've got around here that we start at 0. Okay, so we've got pi on 2 is our 90 degrees, pi is 180 degrees. Okay, 3 pi on 2 is around here, and then 2 pi is all the way around there. Okay. And we've got our 3 trigger functions that we know of, our sine, cos and tan, okay, which all have different values depending on where you are on the unit circle as well. Okay, so they all can be a little bit different, okay, which comes into some of these other things I've got around the outside. So this part here, okay, is called the first quadrant. Okay, so we've got 4 spots, so we call them 4 quadrants. This one's the first, second, third, and 4th quadrant. Okay. You'll see I've got these other letters around there. I use the acronym CAST. Other people use, I know they use all stations to Croydon, different things like that. Okay, but what that tells us about is which ones of our trig functions give a positive solution for the angles in those quadrants. Okay, so in the first quadrant, okay, all of them, okay, will give you a positive result. The second quadrant, only sine will give you a positive result. In the third quadrant, only tan, and in the 4th quadrant, only cos. Okay, and this is all related back to our functions and our graphs. Okay, so we've got our different ones like that look, okay, different things like this. Okay, and then our tan one coming up as well. Okay, and it gives you an idea of where our functions actually are. So it's basically telling us when we're talking about positive values, it's when we're above the x-axis. Okay? And I'll link in a lot more once we get into our trig graphs in future tutorials. Okay. Also here, so our unit circle is called the unit circle because it's got a radius of 1 unit. Okay, which gives us coordinates here. Okay, of 1, 0 for this point, 0, 1 for up here, -1, 0 down here, and 0, -1, and they'll link in just a few minutes. Okay, so we also have different angles here. So we've got some angle here, okay, theta. Now we usually call that either the reference angle or the basic angle. Okay, reference or basic angle. It's just our angle that's in our first quadrant. Okay, so if we're then looking for our angle in the second quadrant, we say it's pi minus theta, or pi minus our basic angle. Okay. In our third quadrant, it's pi plus our basic angle. In our 4th quadrant, it's 2 pi minus our basic angle. Okay, is what we do there. Okay, now, around the outside as well, I also have our complementary angles. Okay, so some identities based on our angles in our different quadrants. Okay, so in our first quadrant here, cos of pi on 2 minus theta, so that's coming down this way, okay, is going to be equal to sine of theta. Okay. Sine of pi on 2 take theta is equal to cos of theta, and tan of pi on 2 take theta is equal to 1 on tan theta. So there's some identities that hold true in our first quadrant. Our second quadrant, okay, so we're past pi on 2 now, so we're saying cos of pi on 2 plus theta is equal to negative sine theta, which, okay, and then sine of pi on 2 plus theta equals cos of theta, and then tan of pi on 2 plus theta equals negative tan of, so negative 1 on tan theta. Okay? In the third quadrant, our complementary angles become cos of 3 pi on 2 take theta equals negative sine theta, and sine of 3 pi on 2 take theta equals negative cos theta, and tan of 3 pi on 2 take theta is 1 on tan theta. Okay? And across in our 4th quadrant, Okay, our complementary angles become cos of 3 pi on 2 plus theta equals sine theta. Sine of 3 pi on 2 plus theta equals negative cos theta. And tan of 3 pi on 2 plus theta equals negative 1 on tan theta. Okay, so unit circle is going to be incredibly important later on, okay, because we need to use it to solve our different trig functions later on, okay. Now, there's a few more things that we need to have a look at. Okay, can't fit all into one. Okay, so the next part that we need to look at as well, okay, is some of our identities. Okay, so tan of theta is simply equal to sine of theta divided by cos of theta. So that's a really important one to remember. Okay, tan is sine on cos. We also have the identity that sine squared theta plus cos squared theta equals 1. Okay, so to put a little note here, that sine squared theta is meaning sine of theta all squared, so everything's squared. Okay, we just put our squared sign there to make sure that we're not putting it here, because then it can be confusing about what we're squaring, whether it's the whole thing or just theta. Okay, so we put our squared after our sign. Okay, now on behalf of all maths teachers everywhere, okay, make sure you say sine. It's not sin. Okay, this tan is short for tangent, cosine, and sine. Okay, not sin. Okay, we also talk about negative angles. So, negative angles are measured clockwise. Okay, so down this way, and these identities make sense. Okay, as cos of theta is positive down here. Okay, well the other two are negative in the fourth quadrant. So we get cos of negative theta, okay, which would put us here, is equal to positive cos theta. Sine of negative theta equals negative sine of theta, and tan of negative theta equals negative tan theta. Okay, so with our unit circle before, our C was down here. It was the only one that was positive. So if theta's up here in our first quadrant, okay, negative theta's down here. Okay, it'd be down here is negative theta. Okay, so in the fourth quadrant we know only cos is positive and the other two are negative. So these negative angle identities make sense. Okay, the other thing that's incredibly important that links in with our unit circle, okay, is our exact values for our trig functions. Okay, now there's a couple of ways to remember them. Okay, these triangles, okay, where we've got an angle of pi on 4 on top and bottom, okay, then 1, 1 and root 2. Okay, and we basically use our normal idea trig, okay, from like year 9 maths, okay, that for example sine of theta is equal to opposite over hypotenuse. So sine of pi on 4 would equal 1 on root 2. Cos of pi on 4 is adjacent over hypotenuse, so it's 1 on root 2. Okay, tan is opposite over adjacent, so it's 1 on 1, and it's just equal to 1. And you'll see these values here in our table. Okay, our other triangle, okay, is 1, root 3 and 2 with pi on 3 and pi on 6 in it. Okay, so this one you've got to be a little bit more careful of, okay, of which side is what. Okay, so if we wanted, say, sine of pi on 3, we go opposite over hypotenuse, so it's root 3 on 2. Okay, but if we wanted sine of pi on 6, we're going to do 1 on 2, so half. Okay, and all of that is summarised in here, okay, along with some other special cases as well. So these other special cases, okay, aren't in our exact values. We can't find them from our exact values, say our triangles. Okay, so we need to know these as well. So for an angle of 0, okay, well sine is 0, cos is 1, tan is 0. Okay, for pi on 2, okay, sine is 1, cos is 0, tan is undefined. Okay, pi is 0, cos is negative 1, and tan is 0. Okay, and again for 3 pi on 2, okay, we've got sine is negative 1, cos is 0, tan is undefined. Okay, and for 2 pi, we get back to what we had at the start again of sine is 0, cos is 1, tan is 0. Okay, so just something else that we need to remember when we talk about our unit circle that I spoke about earlier. Okay, we said about the coordinates. Okay, so for example, this is 1, 0 for there. Okay, now remember, cos is actually our x. Cos is our x coordinate. Okay, so that's why at 0, cos is 1. Okay, and sine is our y coordinate, it's 0. Okay, and remember that tan is sine on cos, which is y on x. Okay, so when you look here at these undefined ones, so where we're saying sine, which is y, divided by cos, which is x. So we're going 1 divided by 0. Well, we can't ever divide anything by 0, hence why tan is undefined for both here and here. Okay, so things that we really need to remember from here, okay, is we need to have a way of remembering our exact values. Some people like the triangles. Okay, I know I used to always remember it as our table. I will admit that I probably forget them a little bit now. Okay, but some people prefer tables, some people prefer the exact value triangles. Doesn't really matter. And again, we need to remember that information that we had at the start of the tutorial about our unit circle. Both these things are going to be used hand in hand a little bit later on when we're solving our trig functions. Okay, check out my next video for some worked examples on how to apply these to questions.